Alright, hey, welcome back to your favorite intermediate algebra course. Good to see you. We're going to be solving linear inequalities today, as well as solving compound inequalities today. So if you recall, um, there's a couple things to remember when you're solving inequalities. Number one, it's typically easier just to get the variable on the left-hand side to make sure that you do graph that properly. And number two, to remember that when you're multiplying or dividing both sides of the inequality, you got to remember to reverse that inequality. Okay, so let's look at this first example here and you'll see why you have to reverse that inequality. So just like you would solve an equation, you're going to isolate that x value. And then right here, to solve for x, you got to divide it by a -5. So again, if you divide both sides by a negative number, you must reverse the inequality. Because let's think about it. Let's say you didn't. Let's say you did not reverse it. So supposedly your answer was x is greater than 2, right? So supposedly 3, because 3 is greater than 2, 3 is an answer. Well, if you plug that in, check x being 3, since 3 is greater than 2, and you plug that in, you got -15 plus 7 is greater than -3, and you're like, wait a minute, -8 is not bigger than -3, right? -8 is actually smaller than -3. It's less than -3. So you've got to remember, you've got to switch that inequality whenever you divide both sides by a negative number, or if you multiply both sides by a negative number. Okay? Just like we did here. So you notice that we switched the thing. It was greater than, we switched it to less than as soon as we divided by both sides. All right, x is less than 2. And then you guys remember that when you graph those things, if I am strictly less than 2, strictly less than 2, that is open. I am not including 2, and it's going to the left, less than. You notice that this thing is pointing left, right? It's pointing in the direction. So if you have your variable on the left-hand side, it will tell you which way that arrow's going, less than 2. Okay, you guys hopefully starting to remember this from algebra. Solving an inequality of the variable on both sides. Okay, so if you got the variable on both sides, again with inequalities, I want them on the left-hand side. So I'm going to actually take that over. 2x minus 3x, negative x minus 2 less than or equal to 1. Get rid of the 2 now. Negative x less than or equal to 3. Now I got to get rid of that -1 in front. I'm like, oh, did I divide by a negative number on both sides? I sure did. So I've got to remember, switch that inequality again here, right? Again, you don't switch it every time, but you do if you divide or multiply both sides by a negative number. So x is greater than or equal to -3, greater than or equal to, so we include that -3, greater than or equal to -3. And our graph, again, is denoting every real number that satisfies the original inequality. So for instance, you notice that the number 0 is on our graph, right? 0 should be a solution. If you were to plug 0 back into the original inequality, you would get a true statement. Okay, so if you're checking it or if the textbook asks you, is this a solution, you just plug it in and see if it's true or false. All right, now let's get into some compound inequalities. So we have two kinds of compound inequalities. You have an AND compound inequality, just like that's shown here, and then we have the OR compound inequalities. Okay, so here's an example of an AND compound inequalities, and we'll do some of these involving absolute value in the next section as well. So this is kind of like two problems in one, these AND compound inequalities. So if you were solving, if you weren't looking at this piece, how would you solve that? You say, well, I just add 3 to both sides, right? Well, sure. Well, if you were looking at just this side of it, say, well, how would I solve that one? I would add 3 to both sides, wouldn't you? So you kind of have, notice you have these two inequalities. You kind of have two problems in one. You're just going to add the 3 to both sides. Okay. So here we go. Add 3 to this side and to this other side, right? Again, two problems in one. Negative 9 plus 3, negative 6, less than 2x, less than or equal to 10. And how would you isolate that x? You say, well, I got to divide by 2. Divided by 2. Now you notice I'm dividing by a positive 2. So I do not need to switch my inequalities. Okay, so how do you read this? So what you do is you read this part first, the x. You see that part first, you read that first. X is less than or equal to 5, and then you read this other part. Let me square it right here. Now, we don't read it that way, so I flip it around. You know, if I change their sides here, I got to change that inequality. I read it this way. X is greater than negative 3. So x is less than or equal to 5, and x is greater than negative 3. So if you think about that, this is an and compound inequality. I am less than or equal to 5, less than or equal to 5. Let's say I was to graph these separately. Less than or equal to 5 and greater than negative 3. Okay? Less than or equal to 5 and greater than or equal to 3. Well, and in mathematics, that's intersection. Where are they both at? Okay, the solution must satisfy both of those inequalities. And I say, well, do you see how they're both right in here? This is where they intersect, if you will. So my actual answer is in red, from negative 3 up to 5. Okay? And we already had our answer right here, notation-wise. So here it is notated. Here it is on the graph. Okay? Oops, I forgot the negative 3 there. Okay? So once you get to this point right here, you really have your answer because you can think about your smallest number is going to be right here, and it's open, right? It's an open inequality, 1, 2, 3, 4, 5. And then the biggest number is right there, and it's closed, right? Because it's less than or equal to, you just put the line in between them, okay? But that's what it means. This is what it means that I put in quotations. X is less than 5, and it's greater than negative 3. Let's do another one like that, okay? If we're to solve this one, we'd subtract 7, right? Subtract 7, subtract 7. And they're like, well, I got to get rid of this negative 4 in the middle here, so let's divide everything by negative 4. And you're like, oh, but I divided everything by a negative number. So I've got to change that and change that as well. Okay? Well, this is improperly written. Okay, you have to have your smallest number on the left-hand side and your largest number on the right-hand side. So if you can imagine sticking this X on a popsicle stick and spinning it around, if you will, spin it around, then it'll kind of show you how to write this thing. So your 0 ends up over here. Your 1 needs to be over here. Your X right there, but this sign goes with the 0 flipped around. And that sign goes with the 1 flipped around. Okay, so this is 0 is less than or equal to x. Or I'm sorry, I said that wrong. X is less than 1, and x is greater than or equal to 0 is how we say that, right? And x is greater than or equal to 0. So here's our solution, and then we go ahead and graph that. We're like, well, it looks like it's 0 is included. You notice that it's filled in, right? Right here. I'll do it in black. You notice it's or equal to that 0, right? And then it goes up to the 1, and 1 is open, right? Less than 1. Okay, so x is less than 1, and it's greater than or equal to 0. Okay, so that's compound inequalities. Let's go on to the next one here. Solving an or compound inequalities. You probably like these ones a little more. What you do is they're written one inequality or the other inequality, and or is inclusive, okay? It's like union in mathematics. 4x less than or equal to 4. Now we divide both sides by this positive 4. So we do not have to switch this inequality. X is less than or equal to 1. Or, and now we just do the other one. So let's do this other side. Plus 3, 2x greater than or equal to 6, divide by 2, x is greater than or equal to 3. So this is actually our answer. That's it. You just do the two problems separately there. And then you put them both on a graph. X is less than or equal to 1, less than or equal to, less than or equal to 1, or x is greater than or equal to 3, greater than or equal to 3. Okay, so this is one or the other. So if somebody asked you, um, is x equal 4 a solution to this problem? A solution. I say, well, let me think about it. If I plugged 4 in, is 4 less than or equal to 1? No. But it's just got to satisfy one or the other. In other words, false, right? Is 4 greater than or equal to 3? True. Okay? So it's one or the other. And it was true here, so I say, yeah, it is. And you notice that 4 is on my graph. It's got to be on one side or the other of this graph. Okay, so or one or the other type of deal. Okay, so it has to satisfy one of those sides there. Let me erase this. And you notice with the compound inequality, on the other hand, it had to satisfy both of those when we talked about how that was. Okay, let's do another one. 2x plus 4 less than negative 6. Solve that. Divide by 2. Here we immediately divide by 3. Okay, and then we just stick an or between it. We say x is less than 5 or less than negative 5, sorry. X is less than negative 5, strictly less than, open hole, or greater, x is greater than or equal to negative 7. Greater than or equal to positive 7 there. Okay? Alright, one last one here. Under ideal conditions, water will remain a liquid when the temperature F degrees Fahrenheit satisfies the inequality. Write the inequality in degrees Celsius, okay? And note that 9/5 C plus 32 is your Fahrenheit, okay? So we're starting out like this, and we're going to make this substitution. Note F equals 9/5 C plus 32, because we want to solve this in terms of C. So I'm going to put that in the middle there, replace my Fahrenheit, my F there, okay? And then we solve this, and you notice we have an and compound inequality. So first thing we do, get rid of that 32. Okay, so we got 9 C. Oh, what's that, 880 there. Okay. Now we gotta get rid of the 9/5. We're gonna multiply everything by 5/9. Well, 5/9 is a positive number, so there's no need to switch the inequalities. Okay, you got 45 over 45C, which is 1C. That's what we wanted. 20 times 5, what's that, 100? And then we got 0 over here. So C is less than 100, and it's greater than 0. Okay, so that's under ideal conditions, water remains a liquid in between those temperatures for Celsius. Okay, all right, bring any questions you got to class. See you later.